All right, if you've ever prepped for a Java interview, you know that sinking feeling when multi-threading comes up. Those questions can be brutal. Well, today, we're going to tackle that head-on. We are going to master the Java Thread Lifecycle so you can walk into that interview and absolutely nail those questions with confidence.
And it almost always comes down to this question right here. Seriously, this is the one. Interviewers love this question because it's the perfect filter. It instantly separates the people who just memorize some flashcards from the ones who actually get concurrency. It looks simple on the surface, but trust me, the why behind it, that's where everything is revealed.
So that's our mission today. We're going to break it all down. We're not just going to give you the answer, we're going to build it from the ground up, starting with a thread's entire life story. Because once you see that full journey, the whole wait versus sleep thing, it's going to click. It'll be totally clear.
Okay, so the best way to think about a thread's life cycle is like it's a map. You've got this main highway, the simple path, and then you've got these tricky little detours and side roads. We're going to start with the main highway. Let's get that down first. The simplest, most direct route a thread can take from the moment it's created to the moment it's gone.
And that main path is just 3 steps. Super straightforward. A thread is born, that's new. It gets ready to do some work, that's runnable. And then its job is done, it's terminated. New, runnable, terminated. Let's zoom in on each one.
So, when a thread is in the new state, think of it as just, well, an idea. It's nothing more than a plain old Java object. Yeah, the JVM has set aside some memory for it, but the actual operating system? It has no clue this thread even exists yet. It's like a blueprint for a house that hasn't been built.
And here's what that looks like in your code. Just this one line. The moment you write new thread, you've done it. That thread object, T, is created. And right there, at that exact instant, before you even think about calling start, that thread is just sitting there, chilling in the new state.
Okay, now things get interesting. When you call start, the thread moves into the runnable state. But hold on, because here's a classic interview trap. You might think runnable means it's running, right? Nope. The JVM actually lumps 2 things together here, a thread that's ready to run and a thread that's currently running.
That's right. It's a super common misconception. People assume there's a separate running state, but if you look at Java's actual thread.state enum, it's not there. So a runnable thread could be one of 2 things. It could be firing on all cylinders, executing code on a CPU core right now, or it could just be hanging out in a line, waiting for the operating system scheduler to give it a turn. As far as the JVM is concerned, both of those situations are just runnable.
And that brings us to the end of the road, the terminated state. Once that run method finishes its job, whether it completes successfully or crashes with an exception, the thread is done. It enters terminated. And that's it. It's permanent. You can't bring it back to life. You can't restart it. Game over. Its story has been told.
All right, so we've navigated the main highway. Easy enough. But now it's time for those tricky detours I mentioned, the waiting states. And let me tell you, this is where interviewers really try to trip you up.
There are 3 of them, and they cause so much confusion. Blocked, waiting, and timed_waiting. On the surface, they all sound similar, right? The thread is paused. But the reason it's paused and what it's waiting on, that's totally different for each one. So let's untangle this mess one state at a time. First up, blocked. This one is super specific. A thread enters the blocked state for one reason and one reason only. It wants to get into a synchronized block or method, but some other thread is already in there, holding the lock. That's it. It's not waiting for a signal, it's not taking a nap, it's actively trying to barge through a locked door.
Next, we have the waiting state. Now, this is all about teamwork and coordination. A thread goes into this state on purpose by calling something like object.wait or thread.join. It's basically saying, hey, I'm going to sit here and wait indefinitely until another thread gives me a specific signal, usually with a notify or notify all call.
And finally, there's timed waiting. This is pretty much exactly like the waiting state, but with an escape hatch, a timeout. This happens when you call methods that have a time limit, like thread.sleep1000 or object.wait500. The thread is waiting, but it's not going to wait forever. It'll wake up if it gets that notification or if the clock runs out, whichever happens first.
Okay, let's put blocked and waiting side by side, because this distinction is absolutely critical for your interview. Remember, blocked is about fighting for a lock that someone else has. Waiting is about politely waiting for a signal. But here is the single most important difference. A blocked thread holds on to any locks it already has. It's greedy. A thread that calls wait, on the other hand, releases the lock on the object it was waiting on.
It plays nice.
And if you want a killer soundbite for your interview, this is it. Write this down. Blocked is about lock acquisition. Waiting is about coordination. One is a fight for a resource, the other is a cooperative handover. It's simple, it's powerful, and it shows you get it.
So, with all that background, with our map of the thread lifecycle complete, we're finally ready. It's time for the main event. We're going to tackle that big question, the one we started with. Let's do the showdown, sleep versus wait.
Okay, your high-level elevator pitch answer is this. Sleep is just a pause button. It's simple. It just tells the thread, hey, take a break for a bit. But wait is way more sophisticated. It's a tool for communication, for getting threads to work together. But let's go deeper. First off, where do they live? Sleep is a static method on the thread class itself. Wait, weirdly, is a method on the base object class. We'll get to why in a sec. Also, you can call sleep anywhere, but wait, you have to call it from inside a synchronized block. But again, the absolute #1 game-changing difference comes down to the lock.
And this right here is the golden nugget, the key takeaway. Sleep holds the lock, wait hands it over. Say that again. Sleep holds the lock, wait hands it over. If a thread is in a synchronized block and calls sleeping, it falls asleep, but it keeps a death grip on that lock. No one else can get in. But if it calls wait, it releases the lock on its way into the waiting room, letting another thread come in and take its turn. It's a fundamental difference in behavior.
This naturally leads to the next level senior dev question. Okay, so why is wait on the object class and not the thread class? And the answer is, well, it's just beautiful, elegant design. See, in Java, any object can be a lock. The whole point of wait is to release the lock on a specific object you're waiting on. So the method has to be on the object that has the lock. If wait was a method on the thread class, and that thread held, say, 5 different locks, how would the method know which one to release? It couldn't. Putting it on object makes it unambiguous. You're always releasing the lock of the object you called wait on. It's clean, it's safe.
Okay, so we've done it. We've mapped out the entire life cycle. We've broken down the toughest interview question. But so what? Why does any of this matter once you've got the job? What's the actual real-world payoff here?
Here's why. Every single time you're trying to figure out why an application is slow, or why a service is totally frozen, or why you have a deadlock, you are debugging the thread lifecycle. That performance problem, it's probably a bunch of threads stuck in the blocked state, fighting for a lock. That deadlock, that's just 2 threads, each blocked, waiting for a lock the other one holds. That weird memory leak, it could be a thread that went into the waiting state and never got the signal to wake up. This stuff isn't just theory. It's your fundamental toolkit for diagnosing the gnarliest production issues.
And that's where I want to leave you. Knowing the states is the first step. Applying that knowledge is the real challenge. Now that you understand these states, blocked, waiting, runnable, you have the building blocks to solve some really hard problems. So think about this. How could you use what you now know to design a system that could detect a deadlock in real time? How could you build a tool to find these problems before they crash your entire application? That's where this knowledge really becomes powerful.